Hello everyone. So in this video, I'm going to talk about how a machine learning model learns. There are lots of machine learning algorithms out there, each of them having its own way of working. The algorithm that I'm going to talk about in this tutorial is called linear regression. The reason that I picked this algorithm is first, it is really simple to understand. And the second thing is the working principle of a linear regression algorithm is the one which is used by lots of other machine learning algorithms, including the powerful neural networks. That is why understanding how a linear regression works would also help us understand how a neural network works. So let's begin our discussion with an imaginary data set where we have X, which is let's say, the area of a house, and then we have Y, which represents the price of a house. The hypothesis function of a linear regression algorithm says that the output of the model is equal to W times X plus B. Now this X here is the area of the house. So it is basically the feature of our data set. It comes from the data here. And then these two variables W and B are called the parameters of a model. These two variables control how the output of the model is going to be. Now, initially, we don't know what we should put those values for the W and B because we don't know that yet. And that is why we just randomly initialize these two values. But because we randomly initialize these two values, the output of the model is going to be something that would be far away from what the true output would be. So the goal here is to figure out what is the value for W and B such that the model outputs something which is closer to what the true output is. Before we learn how to figure that out, let me introduce another concept called the loss function. Loss function is a function that is responsible for accumulating how much the model deviates from the true output. A typical loss function that is used in regression tasks is mean squared error, MSE for short. Its formula says that L is equal to 1 over n. This capital N represents the total number of instances in your data. And then we have summation starting from 1 going up to n, yi minus yi hat whole squared. This yi here is the output, the true output, and then yi hat here is the prediction of the model. So what this loss function is doing here is that it is accumulating the differences between each of the training instance and the corresponding output of the model on that instance, and then it is squaring those differences and summing them over all the training data, and then dividing it by the total number of instances in the data. So initially, because these two variables were randomly initialized, the loss is going to be high. And our goal here is to figure out, to reduce or minimize the value for the loss function. This makes it a very well-known problem in mathematics, which is called the optimization problem. And there are very well tools in mathematics where we can make use of them in order to achieve that goal. Now, closer inspection of this loss function reveals that this loss function is in fact a function of these two parameters, b and w. And thus, by changing these w and b values, we can change the value for the loss function. How are we going to change those values is something that is going to be, that comes from the techniques in order to achieve optimization. One of the most popular one is called gradient descent. So gradient descent tells us that we need to change these parameters w somewhat like this. Now there are two new terms here. First thing is this alpha. We'll talk about that in a second. And then we have this term, which is called the derivative of the loss function with respect to w. Derivatives are powerful tools from calculus which helps us find out how one quantity changes with respect to another one. Here, it tells us how the loss function changes with respect to changing w. Once we figure out the derivative of the loss function, we can then multiply it with another term which is called the learning rate of the algorithm. This learning rate controls how much change should be made in the value of w. And by plugging values for the derivative of the loss function and the learning rate, we can then figure out the new value for w, which would tell us which by plugging them would reduce the loss function. A question that comes to mind here is how is this equation going to help us reduce the value for the loss function? In order to understand this, let me draw a plot here. Let's say I want to plot my loss function against the value of w. So for some values of w, the loss is going to be high, and for other values of w, the loss is going to be low. So let's say if I plot it across a wide range of w values, I might get something that looks like this. So as you can see, for some values of w's, the loss is very high, and then for other values, the loss is low. Suppose that the initial value that we picked for w, which was randomly initialized, was somewhat here, and the corresponding value of the loss at that w would be here. Now, what happens when we take the derivative of this loss function with respect to w here is that we are going to get a tangent line at that point, because derivatives are nothing but the slopes of the tangent lines. So let me draw this tangent line here. And then the slope of this tangent line is going to give us the derivative. The question is, how is that going to change the value of w such that it would reduce the overall loss? Well, if you carefully look at this tangent line here, its slope is going to be a positive value. We don't know what that value is because it's just a generic example here, but that would be some positive value. Now, the learning rate is also a positive value ranging somewhat between 0.01 and 0.05 or whatever, but it's a small positive number. If you take that slope, which is a positive number, multiply it with another positive number, this overall term is going to give you some positive number. And then if you take the previous value of w, which was, let's say here, 3, and subtract a positive number from here, suppose that positive number was, let's say, 2, or let's say 1.5 or 1, what would be the new value for w? It would be equal to, w equals to, initial value was 3 minus this term got us a value of 1. And so the new value for w comes out to be 2. If you plug in that 2 here, maybe this is 2, you'd see that now the loss has reduced from that point to this point, and we have reduced the loss this much. Now, as you can see, the goal is to reach at this point where the loss is at its minimum, and this one step has made us come closer to that minimum value, but still we are away from that minimum point. And that is why gradient descent algorithm is an iterative process. So it doesn't work in one single step. Rather, you repeat this process over and over again in order to gradually refine the value for w, which would make you come closer and closer to the lowest point on this plot. And by the time you reach at that point, maybe the next step gets you here and here and here. By the time we reach this point, at that point, the slope of that tangent line would be 0, because that is now a flat line here. And since that would make this term, overall term, 0, if you plug in the value for w here, that term would give you 0, and there would be no longer updates made to the value of w. And at that point, you can say that my model is now trained, because I have reached the minimum point at the loss function, and I cannot go below that. Now, I've explained this process just in terms of w, but the same procedure is applied to this bias term, b, and similar way, we update the value for the bias unit. And once we have reached at that minimum point, at that point, we can say that algorithm is now trained and it is being able to make correct predictions. Now, this is the overall working principle or training principle. This training principle is also applied across a wide range of other learning algorithms like neural networks and some of the other popular machine learning algorithms. I've also written Medium tutorial on this, the video tutorial that I'm doing here. You can go check it out here, where I have explained it in using these plots that are true using Python and stuff. And you can also find some other of my machine learning tutorials there. Thank you.